So in this video, we're going to be solving a titration problem. So, so we have given right here a volume of phosphoric acid, and they're saying that it needs this volume of this amount of molar of potassium hydroxide to reach equivalence point, and we want to find what is the molarity of phosphoric acid. So you remember this equation, we have the molar is equal to the moles over the volume. So right here we have the volume. Our goal is to find the molar. So what we're going to do in this problem is, using these two pieces of information given, we're going to find the moles of H3PO4, and we already have the volume of H3PO4, and then we could just plug those two into this, and then we could finally get the molarity of H3PO4, which is phosphoric acid. So let's just jump right into it. The first thing you need to do is write out the equation, the reaction. So you have H3PO4, okay, and then you're adding that to potassium hydroxide, and that will yield, okay, so this is a double displacement. This could also be, oh yeah, so the H pairs with the OH. No, neglecting the subscript, whenever you have H going with OH, you would get H2O. And then you worry about the coefficients later. And then, so then you would have plus potassium phosphate, so PO4. And you would put a 3 right here to balance that, since this one has a 3 minus, this one has plus. So right now we have to balance this equation. So if we have 3 potassiums, so we could just put a 3 right here. And now we have a total of, okay, so we could put a 3 right here, and that would be balanced. So if you could check it, let's see how many H we have on this side. That would be 3, and then plus 3, that's 6. Let's see, on this side we have 3 and 2, 6. How many oxygens on this side? We have 4, and then a 3, that's 7. So then we have a 4 right here, 3, 7. So how many potassiums? 3 and 3, phosphate 1 and 1. Alright, so that's balanced. So now that we've balanced it, and then we're given that there are, so we could find the moles of potassium hydroxide using using this equation, the capital M molar equals moles over liters. So we multiply these two to get moles. So that means we have, if you multiply, well, you want to convert the milliliters into liters. So if you so you just divide by 1,000, you have 0.1292, and you multiply that by 0.281. So that means we have how many mole? We have 0.0363 moles of potassium hydroxide. And you could look at the, so you could look at the ratio here. It's a 3-to-1 ratio. So that means if you have, for every 3 moles of potassium hydroxide, you have 1 mole of phosphoric acid. So that means you could divide this by 3, and that would give you the amount of moles you have for phosphoric acid. So you have how many moles of H3PO4? So we have, once you divide this number right here by 3, you get 0.0121 moles of phosphoric acid. And now that we have the moles of that, we plug it into this equation, and we already have the volume. It's given right here, the volume. So you divide this number right here by the volume on top. So 0.0121 divided by 0.2495. Notice I converted this into liters. And so then our molar would be, once you divide those two numbers, you get 0.0485 molar. And then that should be your answer, and it's right here. That is E.